In this video, we will work on a plotting package and language that allows us to graph and understand the data. One of the main reasons to visualize or plot data is to understand what the data is, like what the data came from, certain circumstances underlying the data. That's the primary reason. There's another reason is to understand problems in the data, and in this case, we're going to be interested in outliers, so things that might affect analysis that you might do or concerns you might have about features that you create. So a few different reasons to use plotting. We're going to use the package ggplot2 that's included in the tidyverse, and we're going to use the same data set we've been using. And I'm just going to introduce several different graphs and talk a little bit about what you can learn from them. Okay, so I have this data set. It's called DTA now, and this is the basic language that we use for ggplot2. So it starts with a ggplot function, and that takes a data frame and then gives some language about what goes into the plotting. But this part just is the setup. It doesn't do any plotting itself. So the data frame, then X or Y, or X and Y, or just X, and other things that you might put in here to alter what the eventual plot will look like. So this AES is like the features of the graph that you want to work with. And then to put something new into the graph, output is you do plus for adding a new feature or a new part of the graph. And here you need to add a graphing function. So here, this is a histogram. So there are two things, GEOM, GM, histogram, and then there's a stats plotting function that aggregates things and calculates things before plotting. Mostly we'll just use these types of things, and we'll see a bunch of them as we go through. Okay, so this creates a histogram using sales quantity as the X variable and the data frame DTA. When you run it, the output goes down here on the bottom right in this plots tab. And let's talk a little bit about what it looks like. So count is the number of observations. Sales quantity is the column sales quantity that tells how many units were purchased on that transaction. And what can we learn from this histogram? Well, there are transactions that have it says it's 0, but it's really slightly above 0. So it's low levels of quantities. So lots of transactions were happening with 1 or 2 bike purchases or something like that. And then there are plenty in this range, and then once we get up to about 25, there are very few transactions at that level. Well, as you go out here farther, the reason the graph goes all the way out here to a 100 is that there are some transactions that are out here in the tails of this histogram. So when we have something way out here, that is an outlier, right? So it's not with the bulk of the distribution here. What this will mean is in lots of things that we calculate, lots of the analyses. So for example, a simple thing like calculating a mean, those types of calculations will end up with being heavily influenced by something out here. So that may determine some things we do to alter the data in some way. Or let's say perhaps this was an error. So if the number really should have been 10, but instead someone input 100, then that could be an error that we could go back and fix. If it's not an error, then it just tells us that there are a few that are unusual relative to the rest of the data. So that will influence the measure we create, or maybe the types of analyses we do. All right, so there's a histogram. The next part here is the exact same plot, and we'll only do this once so that you can see some of the options. but notice it has the ggplot function, the geom histogram function, and then a bunch of other things. Everything else here is just to alter the look of the graph. It doesn't change the substance of what's there. So let me walk through just a little bit here. So in the plotting function, you can change some features of that. There will be some others where we change it in this AES part of the commands. And usually when it goes into the AES part of the commands, it's when we're going to do something by groups or something like that. Okay, so we're going to do the sales quantity again. The color of the line is what color deals with the lines. We're going to make this black. The fill of the plots, we're going to make cadet blue. You can look up other colors just by searching up the R color palette, if I can remember how to spell it. So if you just search R color palette, there are some different options here for you. So for example, the first one, you can go on here and look for a big combination of colors that you could use in R. And there are other ones as well, but I found this one I'm going to use. Then the labels give us the X and the Y axis labels and the title. So I'm putting in a title, sales quantity histogram. The X variable, I'm going to say number of units per transaction, which is what sales quantity is. Y is the number of transactions, so I'm just changing those titles. There are also themes that you can use. Again, you can look up themes for plotting. So if I search ggplot2 themes, you can look in here and see different themes that are available. And what that does is provide a bunch of options that with only one change will change the look of it. I like using Theme Classic, especially because I do academic publications and most of those look more like this. And then you can alter the theme as well. So there are parts of the theme that can be altered. So in the theme function, I'm just changing some of those. So the plot title, here you can change the element text, and there are other options as well. Here the title, element text, changing the size. Here I'm changing the horizontal justification, so I'm centering it. I'm making the size of the title bigger than the size of the axes, and I'm making the font bold. You can do italics. Lots of options here. You don't need to exhaust all of the options, but I just wanted to show you some possibilities. There are other things. If you look up the ggplot2 function, package, that's part of the tidyverse set of packages. So you could go here and you can look and see the cheat sheet as well as a bunch of options that are available. All right, so what does this look like when we make all these changes? Notice it makes it sort of look, I don't know, more sort of professional, or at least alters and gives you different options for the way this can look. You can mess around with those, get something that you think looks good, and a lot of these things you can just reuse over and over for every graph that you're going to use. I haven't included these options in all of the other graphs we're going to do, just to avoid throwing this at you over and over, but you could put these in all of the graph options. Okay. So what else might we do? Well, if we have these big outliers, in the last video we talked a little bit about some of the creating the features and altering them. Well, we could transform sales quantity by taking the natural log. Notice everything else is the same. I just did the natural log of sales quantity. Same graph as before. Well, what happens here is, notice it pulled it in some. It still has doesn't have sort of a normal distribution with a mean around the center, but it doesn't go out quite as far out here, right? So compared to ones where we can see the number of observations, there are only, it doesn't go out quite as far out here. What that would do is have those extremes have less of an influence on the on whatever functions or analyses that we might do that are affected by this. Okay, so that's one option, and that helps us sort of see it a little bit better. We could also alter these and look at groups. So here in the AES part of the function, the fill I'm setting equal to the sales organization. So remember, the sales organization is US East, US West, Germany North, Germany South. Well, what that's going to do is take each of those and fill it with something different. So if we run this, notice this is just changing the look of it again, creates a legend here for us. Why are these two different? That's because it thinks they're different in the data, so we would have to clean that up a little bit. The two Germany North versions, my guess is this one, this one has a space, this one doesn't. But it sort of shows by group how many quantities they cover, right? So at the small quantity, the largest would be US East or Germany, the two of Germany North, right? So it's this whole area or this whole area. They're pretty similar in size. We get to the higher price items, so maybe here, and notice that the higher price items, the US East is larger than the Germany North ones, and sort of like that as we go out here. US East is bigger and sort of dominates at the higher price ones. So it gives us a little more information about the data that we're looking at and maybe control some of the outliers. Also, since we see that there are differences across the sales organizations, we may want to consider that when we create features or when we do the analysis later. Okay, next. A box plot is also another common way to look at outliers and understand the data. Here I'm going to do net sales rather than sales quantity, just so you can see what that looks like. And this geom underscore box plot is the way to do the box plot. And normally what a box plot looks like is it has a square with lines on either side. Well, when the square is, or rectangle is so small here, and all you see is a line of dots, this means that the bulk of the data is small and that there are lots of dots that are far out there in terms of outliers. So if we did this with the histogram, it would look similar to the other one that we saw, but there are lots of values that are very large compared to most of the data over here. So in terms of the net sales, so remember this is the sales per transaction. There are some out here that had 150,000 euros or dollars, way out here. So if we do the natural log of that one and look at the box plot, does that fix some things? Well, notice it brought in the tail of the distribution over here, so it's much more manageable. So what we see here in the box, this is from the first quartile to the third quartile, so this is the 25th percentile to the 75th percentile, and the line in the middle is the median. So the fact that the median doesn't seem to be in the middle is because there are larger values that sort of push these parts out a little further, and we have a bunch of them that are really far out here. Okay, so the natural log seems to take care of some of the extremes, and we do have these tails give us the idea of how far out these outliers are. So we've got these extremes here. We can do the same thing when we fill the the plot by organization, so we can do the same thing here. Well, notice what it did is it didn't fill it up the same, it split it into groups. So now we have the two Germany North ones, which again we should clean up, and the US East and the US West. Well, when we take the natural log, they seem to look sort of similar. Germany South has some larger sales in terms of the tail and in terms of most of the distribution. The US West, notice that they have some also that are out here in the tails. US East, their median sale is slightly higher, but they don't have extremes that are so far out there. Okay. Well, we can plot the individual points rather than sort of get an idea of the whole distribution here. And usually we do this when we compare X and Y values. So here we're going to do the sales quantity with the net sales number. Well, some of this is linear because we have a fixed price for the bike or the helmet or whatever it might be. So having more quantity means you will necessarily have more sales. So the scatter plot is geom_point. Takes a little longer because it actually has to plot all of those points. And notice we have different lines here, and that is because up here a larger quantity of a certain product, so this would be the high-priced bikes, then increases up to here. Notice we don't have as many of those, so the company isn't selling large numbers of the highest priced bikes. The lowest price of this group of the bikes, notice there are a much larger quantity of the slightly lower priced bikes, and then in the middle there's sort of a mix of those. And then these very low priced items, notice having more of them doesn't increase it up to the sales of these other higher price items. We could also look at the products. So here we can, instead of doing fill, I did color, and it will plot the color by the product. It's going to be a little difficult to see because we have so many products. So see, we have all these products, so we can't see all of the colors here. But notice the men's off-road bike, that's going to be in this group here. We've got a couple of these, so why do we have one that is slightly higher and one that is slightly lower? Well, this lower one they're getting a discount. This one is not getting a discount. These professional touring bikes, they're the highest price here, and they're they're sort of up here. And then some of these low price ones are down here. Okay, that would be like the water bottle and water bottle cage, maybe the air pump. So again, gives us some options to see a little bit more of what's going on. We also might want to do a line plot, which would be similar to seeing a scatter plot. We're looking at an X and Y variable. Here I want to do year and total sales. So I need to create those. So each year I want to know what the total dollar value of sales for the company was. So I'm going to group by year, then I'm going to summarize to add up all of the net sales. Now if we open the data frame, we have each year a total sales number. And X is going to be year, Y is total sale, and instead of geom_point, we're doing geom_line. So we can run this part here. And notice it creates a line. So I only have 4 points, but 2008 to 2010 and then back down. Well, that means their peak was in 2010. It sort of declined a little bit from there. Well, we can also add another element, which is a second plot. So in adding to the line, we add a point. So we can run this again. And notice it plots the line and the points on the line. Okay? So if we were interested in doing some sort of analysis, thinking about when they had lower sales versus higher sales, we might treat 2008 differently than 2010, for example. Okay, we can do something similar using a different type of a plot. So I have the same thing here, summarizing total sales by year. I just included it so you could see that I'm doing the same thing again. And instead of the line and point, I'm doing geom_column, and it's going to create a column graph. So same sort of thing. Now it creates these bars instead of the line. And the same sort of things apply in terms of colors and anything else if we wanted to make it look different. Okay, so what if we want to look at this by sales organization? Well, look in temp. I didn't have anything by sales organization, so I couldn't graph that. So let's change that a little bit here. We're going to do by sales organization and year, and then sum up the sales. So now I have sales organization and year and total sales. And so notice I've got something going on in here, some hidden difference between these Germany North ones that I would have to fix. Okay, so let's plot that and see if we fill by sales organization, similar to what we saw before. So the total sales of Germany North, of Germany South. Notice the largest total dollar value of sales is US East. US West is smaller, so the largest is going to be in terms of dollar value is US East, then followed by maybe the two Germany North and South are pretty similar. US West would probably be last, maybe. Well, we can plot this just slightly differently. In the column, we can do this position equals dodge, which just means separate the different fills. And so instead of stacking them on top of each other, it will spread them out. So this gives us a little bit better idea. So US East, much bigger than Germany South, but Germany South probably next. But if we combine the two Germany Norths, looks like it would be Germany North, then Germany South, then US West. So lots of other options. If you go back and look at the ggplot, there are examples as well. So tidyverse. So we have this. We have the cookbook here that this is another online book that you could go through and find other sorts of things that tell you how to make the graph, sort of like what you saw in the video here. You also might be able to go get the gallery. So, and it all sort of looks like this, right? It creates one for you that you could then go and see. Sorry, I had to go find where it was. So if you search ggplot2 gallery, it has a bunch of examples that you could go click through and find the type of graph that you want to do. So it gives you plenty of examples. Let's do one sort of like what we just did. So if you clicked on the example, you could go in here and see their different graphs. And you look at the specific one, it'll talk about it, and it will give you some code to figure out how to do it. So lots of examples and help out there. One last one, just for fun, because it might be useful in what we're doing, is this world map one that I showed in class. So one of the packages in the plotting packages in the tidyverse includes this world coordinates. And if you look in here, it just has a bunch of longitudes and latitudes and other information here. Well, that's all of the coordinates to create these, the graph, which is 99,000 coordinates. But if you plot it, so you can do this geom_map, which creates a map, and you input the world coordinates and map it, and then the things that go into it are the longitude and latitude plus the region, and you can color it as well. That's not one I think you'll use so often that you have to memorize anything. I would just save it as a possibility. Notice it graphs the world here. There are other graphs, location graphs you can do as well. If you wanted to add something on top of that, you could take some of what we have. So we had these 4 areas: US East, US West, North and South Germany. I just searched online for their coordinates, so their longitudes and latitudes, and I gave them a rank where 4 has the most sales, 1 has the least sales, and so created that data frame. If we open that, notice it has a longitude and a latitude, which is what we primarily need. Rank, I'll show you how I'm using it. This is just the location where I'm calling these longitudes and latitudes, and it's for this sales organization. So we plot the map. Notice we add something to it. We can do this geom point, and in this we have to tell it the data we're going to use, because we're using a different data than what that was in here. Notice we're not putting it in the ggplot function because we're going to specify things differently for the geom_mat and geom point. Don't have to memorize all this, you can just try it. So data frame here, and the AES we're going to use is the longitude and latitude. We're going to color it by the location. So if we look back here, the location was DC, Sacramento, North and South Germany. And the size we're going to make of the circles is by the rank. So I made the largest one the largest rank. Alpha gives us how transparent it is. 1 is not transparent. And then we can remove, so we're altering the theme. That's where we're putting the legend. I'm just going to remove the legend so it doesn't show up there. So if we plot this now, it's going to do the same thing, and it just gives us some spots here. So notice the largest here, US East, North, well, I don't know why it has this, but the Germany's here, you can kind of see this one, you see this one here, and then the smaller one here for US West. Okay, so some options. This one I think is just fun, but all of these other ones are ones that we will use much more frequently. If you mess around with them, try and do things. The key here really behind any graphing is learning something about the data from the graphing. Just being able to do the graphing on its own is nice, but it doesn't help you learn about the data and what's going on. So have a little bit of fun with this, and we'll start to incorporate it with other things we're doing.